All right, we're live. I'm going to share this, and that's going to do that. Yeah, I know. I love how it does that. Google does such a good job. All right, so we are here to talk about today integrating SQL Server with Hadoop. My name is Pat Wright. Hopefully I've got a chance to meet everybody. I'll talk about myself in a minute. I like to do a presentation that has about 25, 30 minutes of content. You'll notice it's a 1-hour session. I love getting questions. Feel free to interrupt me. I like to have conversations with my audience. I like to have you feel like you're contributing and find out what you really want. I've been through this. This is not fluff. This is what I've spent the last 2.5 years doing. So I'm more than happy to answer any questions. Just this morning, I fought a nice, wonderful code red all morning long with one of my issues this morning. So you're welcome to come and talk to me about it or talk to me during the session. I'm happy to talk about these things. All right, so first and foremost, let's say thank you to our sponsors. Without that, this event could not happen. I know that I put in a lot of time and things like that, but if we didn't have their money, none of this would be here. You're eating today because they gave you money. So please stop by Think Big and Journey Team's desk and give them a notice and talk to them and let them feel like you are interested in their products, because you should be interested in their products because they're very important and they're part of our community. So they make all of this possible. All right, and why did I get up on my screen? That I don't care. All right, so as I said, my name is Pat Wright. I like to present and talk and do things like that. I like to help people. I do photography on the side a little bit here and there. I've been a SQL Server DBA for about 10 years, and then I got into big data stuff over the last 2.5 years. I was a SQL Server MVP from 2006 to 2007, and I've organized and run a lot of events. You're always welcome to find me at @SQLAsylum on Twitter or SQLAsylum@gmail.com. That's what I go by, and you can come and see me afterwards for a card or anything else. Always happy to answer any questions you might have. My speaker rate profile is that little QR code right there, so feel free to rate me. Please fill out your sessions in the back. Please do them online. Don't fill out the paper. Scan the QR code and do it online, because then I don't have to enter another piece of paper into my system. So Sunday afternoon, I typically spend reading my reviews and all the reviews, and I would love to hear both positive and negative feedback. Be very constructive in your feedback. It's very important to speakers. Okay, so what are we going to actually talk about today? We're going to talk about what problems we faced and why we chose a big data solution and why we are moving away from our relational database. And when I say relational database, this applies to MySQL, Oracle, SQL Server, DB2, basically anything. It's the same ideas, it's the same concepts, it's just different tools and how you use them. So I'm going to talk about SQL Server specifically for this demo and for what I'm doing, but it relates exactly to MySQL, to Oracle, and to all the others. It's the same thing. So the problems we're facing, the solutions we found, and then we're going to give a demo on it. All right? So first of all, let's talk about what is big data. I really kind of left this slide in because I like to talk more that I don't like this slide. It's kind of strange, why would you leave it in? So a lot of people love to define big data as these 4 Bs. It's actually 5 Bs, but I don't even bother with the 5th one. Big data should be whatever you make it, okay? Big data was a marketing term that someone came up with that said, hey, that sounds like a good idea. It's not any new problem. In 1980, we had 1.44 floppy disks, or maybe it was 85. We had tiny little floppy disks, and you know what? Your Word document wouldn't fit on that floppy disk. That was a big data problem. Okay, so this is not new. This is not a new concept. This is not something that just sprung up out of the middle of nowhere. It's the same problems you face today that you faced yesterday. You just have new tools available to do something about it. Okay, I really hate the term big data, but I have to use it because everybody wants to talk about it. It's marketing. Come on, what am I supposed to do? So it is an old idea, and it's a concept with new tools. Doesn't mean that it's brand new. Don't be afraid of it. If you had a problem with queries 3 years ago because you had a 1 terabyte database, that's still a big data problem 3 years ago. Whether you're using SQL, Oracle, MySQL, or Hadoop, it's still the same thing. It's still a problem, okay? Anyone else want to give it a definition of what they feel big data is? Yes, sir.
So just actually this last week, NIST has, we saw they released a draft paper on big data and trying to put some standards around it at that level.
Okay.
And they defined it in I think, one of the better ways, which is you have big data, you're dealing with big data when you design your infrastructure and your scaling mentality around the fact that you're dealing with big data. And while it's a self-referential or recursive definition, I think it actually has merit, because the idea is, instead of just saying, I'm going to build a really powerful big iron machine for my one database server, and if I need two of those because I have an accounts DB and a billing DB or something, then fine, I might have to do those for those reasons. Instead, in a big data world, you're saying, I have to have an environment that can scale, that can grow, so that I can not only store a lot of data, but that I can access and do something with that data.
Okay, so to restate, because I'm going to be on the recording too, what it sounds like, if I summarize a little bit, they're really saying that the big data really relates to how you architect and how you horizontally scale the systems to deal with everything moving forward, to think about that. And that's a really good definition. I really like that, because a lot of the reason that I went to the solutions I went to was about horizontal scalability. I don't want vertical ceilings on my relational database. I don't want to spend $2 million to buy an Oracle appliance that just goes straight up with 2 terabytes of memory in it, because it's one box. It's not 300 boxes spread out. So it's a great consideration, and that's a good definition as well too. The one thing that you should always be worried about, though, is when somebody defines it, don't let them put size into the equation. Okay, my solution, everything I'm talking about, is probably about less than 1 terabyte's worth of data. Okay, I do not have petabytes. I do not have exabytes. I have a terabyte. That's it. And I'm using all the tools that are available out there. You don't have to have tons and tons of data. Okay, you have to have data problems. That's all. All right. So who are we and what problems do we have? Work for a company called Merit CX. Merit CX is a software as a service company that provides customer solutions that help make happier customers. We help collect feedback about your customers and make them happier customers. We rate them, we report off of them, we give you analytics all about them. We gather all this data together and we say, this is why your customers are unhappy, and here's what you can do about it. That's what we do, and that's how we bring our customers' data together. Okay? So we had a typical situation that you see out in the relational world, or out in the world in general. We had a website out there, our customers logged into it, they were trying to query data, and they had a nice dynamic search filter, say, hey, I want to see this question, this question, this question, I want you to give me a chart on that. Well, that was queried against a relational database, SQL Server, and obviously you've got stored procs and you've got query execution plans, and it runs a little slow, 5 minutes to run a query. You have the common thing, and you have data coming in from surveys and from collections that give you all that data coming in as well. So you've got a blocking situation. You've got reading and writing from the same place, same source. Okay? You're not optimized for reporting because your structure is third normal form. It's a very standardized database. So you have all the common issues that you're going to normally run into. So let me go through some of the options that we went through to solve this problem. Okay? This just kind of relates to the same thing I just said about the problems. It wasn't scalable. We could only go vertical. We have a SQL Server. We could really only go up. We could still scale out to multiple databases, but anybody that's done that, it's a nightmare. And everybody that wants to bring up 2014 and availability groups, love them to death, but try to do them across 500 or 1,000 databases, and they're not going to work. Okay? So current architecture looks something like this. We've got a lot of data coming in from different locations. These are all custom products that we built. None of these are really off the shelf. They go inside their SQL Server. There's a service that queries the database and a website that talks to that service. Again, a simple model that says, go and get me data and return it to my browser. Basically, that's all it really does. So again, you've got contention right here around this big square, what is that thing called? Cylinder, thank you, in the middle. I was gonna get it out sooner or later. So the options you can look for, what can some people think about? What are some of the options out there in the relational world you can do to rectify this situation? I need candy bars to throw at people. You usually have candy bars. Tunings, okay. So tunings is a great thing. Optimization, absolutely. Store procedures, indexes, make the thing faster, help that out. What's gonna happen if you keep going down that path? What?
Complexities.
Complexities. You know what else is going to happen? You're actually going to succeed. You're going to make it so fast. You're going to get queries. You're going to get indexes. And you know what's going to happen? You're going to lock it. Then it's going to run into concurrency issues. And then you're going to get deadlocks. And then your life's going to really get ugly. So, okay. So another option that you can choose from is, my favorite option is replication. Replication is wonderful. If you're a MySQL person, replication is probably the bee's knees. I love that replication in MySQL. I hate SQL Server's replication. Just a thing. So you can replicate the data off to another SQL server, off to another MySQL server, and then query the data from there. Now you've separated your reads and writes. Wonderful, great. What are some of the problems with this? Still haven't woke anybody up. Yes, sir. Real time?
Yeah.
Real time. Good one. What else?
Synchronization.
Synchronization way in the back?
When you have the same ceiling, it's still going to be.
You have the same vertical ceiling. Very good, Dave. Absolutely. The other major issue is maintenance. Now you got two of these. You've got even more problems. You've got the same ceiling on the other box over there, and you've got more of these to deal with. So you've got maintenance and you've got replication. You have all those things, latency, all those problems. So we did try this, okay? I'm putting these up here because we tried these. Our first part of our going to the system was an attempt at this. And we did a customized replication so that it worked a little better than the SQL Server replication. And I can tell you, it couldn't keep up. Couldn't do what it needed to do. It never met the needs of what we needed. Yes, sir.
What kind of replication? Like what the interval? Like nightly or?
Nope. This one for us was hourly. It was a batch level thing. It tried to move hourly, and it moved the data over to another system. That other SQL Server had tables that kind of summarized and aggregated. It had some indexes on it and made it a little faster, but we still had all the maintenance that goes along with it and the cost as well. Because now instead of one enterprise SQL Server, we have two. So there was another cost. Anything else? Did I have another question? Yes,
Did
Dave.
you guys try database mirroring?
Database mirroring. So database mirroring in SQL Server 2008 works beautifully, but try to do it on more than 5 databases and you will fail badly. And we have over 500 of them. So database mirroring at that level does not work. Again, that's where I would love to have a MySQL system do it because it does it a little better, but still, let's take a MySQL system and do 500 databases. It's still not going to be that much fun. Okay, so. All right, next option, my other second favorite option is cubes. I love cubes. Cubes are so much fun, right? Everybody loves cubes. So what's the advantages to cubes? I said advantages, not disadvantages. Don't bag on them yet.
Very fast.
They're fast, I heard, pre-aggregated. Yes, all the wonderful things. They are fast. As a matter of fact, they are still one of the fastest systems you can get when you actually start querying the data. Hands down, they're there. But you have to pre-aggregate them. What does that mean? That means a long load time. What?
CPU cycle.
CPU cycles, yes, they eat up things. So their disadvantages are they take a long time. Not only to develop, but to run, to process, to do everything, and they are hogs for hardware. When we got ours working, for the 1 terabyte I was talking about before, it was a seriously large box and very large Fusion IO cards to make that thing run in less than 14 hours. So that guy loves to eat up hardware, and they are not really terribly scalable because again, if you've got one of them, maybe it can run say 5 or 6 cubes, but try to run a couple hundred cubes off of one server. Yeah, it's not a pretty picture. So again, that's why we looked at the cube solution. Okay, so those are some of the solutions we looked at. Anybody want to guess any other ones that could come up, that you could try?
Sharding.
Sharding, so you can separate the databases out into different places. That's a lot harder with SQL Server because there's not a lot of good built-in tools for it. There's partitioning, and you can also separate it to other SQL servers. But you still have multiple SQL Server licenses for every single box too. So definitely a great point. I love that point, but keep that in mind as well. Okay, so next thing, what did we actually come up with a solution? We came up with both a highly scalable solution. It cost a lot less, and it was very quick to access the data. And this is my prettier picture. I used to have a much older picture to this, but one of my teammates does an excellent job of pictures, and so now I get this beautiful one. So let me walk you through this now. Right here is our relational database, and as you saw in the previous pictures, we had the 3 collectors. We had the 3 things bringing data in. Those are still there. They're still pushing into that relational database. For us right now, Our relational database is our master system of record. It has everything that we need, okay? It's all right there. It does not, we do not files or anything else, it's all right there. We take from that relational database, we use a program called Scoop, SQL on Hadoop. That's what it stands for. I'm going to show you the exact demo of how to do this in just a minute. That little program queries 2 tables that we have, and it pulls the data across those 2 tables into Hadoop. And at the same time, it makes a Hive table right there. And that Hive table is what we then query to push into Elasticsearch. Okay, this is a batch system. It's a 1-hour batch. That's how we currently do our system right now for our reporting needs. The Scoop process runs before this. There's a, let me see, did I have it? Yeah, we use an Uzi workflow. Think of SSIS as a workflow, something like that. The workflow calls a store proc that populates the 2 tables we're looking for, and then Scoop pulls them over, and then Hadoop does the actual ETL work. Okay? So, how many people have a general idea of what Hadoop is? Okay, that's a much better number than the last time I did this presentation. That's good, we're teaching people. Hadoop is a multiple parallel processing system. I hate saying that altogether. Horizontally scalable, lots and lots of boxes, lots and lots of pieces. We take our data, we put it out onto those pieces, and then we run ETL on it so that it can be quick and it can be scalable. If we want our ETL to run faster for our thousands of customers, we add more Hadoop boxes. We get more task slots, we get more things done, we can keep adding to it. Okay, that is the beauty and the nature of a horizontally scalable system. Now, what's the problems with going to, what are the problems with trying to query from Hive? How many people have queried from Hive? Okay, a few people. And you probably did this at some data warehouse request or something like that. You said, let's get the data into Hive. We can query these giant queries, and we can query faster than SQL Server. How many people told you that Hive is faster? Okay, hopefully nobody. If they do, smack them for me, please. Hive is slower than SQL Server, much slower. It does a very large MapReduce task. It is not going to be faster than SQL Server. So everybody always asks me, then why did you take it out of here? How have you gained anything? Because I didn't stop there. I went to a speed layer. I went to a layer known as Elasticsearch that gives me my speed and performance. Elasticsearch is a distributed environment as well. It's an indexed environment, and indexes inside memory. So it moves everything into documents, it indexes those documents, and then queries them very quickly. The standard query time for an Elasticsearch query is under 300 milliseconds. The standard query time for my SQL Server is 5 seconds to 1 minute. So that's the difference of what they're getting. So now my customer's website is right up here, and it queries directly not to Elasticsearch, we have a service, but it queries to that service, and that's how it gets its data now. So instead of querying down to the relational database that has very slow query times, it has very fast query times. Yes, sir.
So this is the second time I've seen your presentation on this.
Mhm.
And I'm wondering about, I mean, I understand Rivers is going away, but why, I mean, it always seemed like the best thing would be, I want to get it in Elasticsearch. If I can get it directly from the database, why wouldn't I do that? That doesn't scale for you? That
Why would you do that instead of Hadoop? In other words, what you're asking is, why did I bother with this middle tier right here?
Yeah.
Why didn't I go from relational database to Elasticsearch? One, my relational database is not in key value pairs. Our Elasticsearch document structure is in key value pairs. I need something to do that work. I could have done that work inside SQL Server. I could have wrote a bunch of stored procedures inside here, done that work, and then pushed it to Elasticsearch. But that does not get me any closer to the horizontal scalability. That just means my SQL servers are going to do a lot more work that they don't have to do. My goal is to try to limit and shrink that giant footprint. The more I can limit and shrink that giant footprint, the better off I am. So as I move forward, I needed a middle tier that helped me to do that. And that middle tier was Hadoop. Okay, that answer the question?
Yeah, I think so. In other words, a lot of the work you're doing in the middle tier would have had to be done in the
Inside
RDBMS.
SQL Server,
Yeah.
yes, yes. Because Elasticsearch is not a great ETL or anything. It's a store, it's a search engine. I mean, it's a Google or something else, just a search engine, that's all it is. So don't try to make it go and, hey, I want you to process this and figure out this, convert, and blah, blah, blah. Don't make it do that. You want to make it do exactly what it was designed for, speed. That's it, searching speed, nothing more. So that's why we went that way. Excellent question. Any other questions while I'm on this? I'm going to come back to this because this is my favorite slide where everybody sits here and asks me questions. So I will come back to it, but I want to do my demo too. Yes?
You mentioned mapping to or translate performing to mean value pairs. Any aggregation or other activities going on besides just name value pairs?
So in this instance, and I'm going to say that because we are looking at some new changes and new things to do, we made the call that whenever you talk about aggregates and things like that, cubes and everything else, you have to decide where you pre-aggregate your data. You do it in the ETL step, push it into a warehouse, or you find a really fast front end that it can pre-aggregate for you or aggregate it for you on the fly. We chose to aggregate our data on the fly. So no pre-aggregation is done here. We simply do some mapping of data. There's no counting, there's no summing, there's no aggregates whatsoever. This guy does it all because he has the power to sum and aggregate and count. Now, there's problems with that. It's always a plus or a minus game. There's always positives and negatives. If we did it here, we'd have a lot more scalability to those aggregates, and we'd make this thing do a lot less work. But now, Elasticsearch is doing a lot more work than the other side. And we're starting to find some places where we're going to have to balance this out a little bit, where we're going to have to do pre-aggregation of data. So, does that answer the question? Okay. All right, let me get to the demo really quick. I want to show you the demo. The whole point of this demo, the whole idea that I'm trying to get you to here is that if you're in a relational database world right now, you should force yourself into a 90-day proof of concept. Everything I show you can be done in 90 days. And as a matter of fact, if you go to the Hortonworks site, which I'll show you, they have exact steps on what to do. I'm really not doing much more than showing what they've already taught. I'm just putting it in a better picture. Because that 90 days, if you can show I can take data from here, I can process it in Hadoop, and then present it to a business user, that could be huge, okay? You're not to the Elasticsearch layer, you're not to that app side, but you're getting there. And once you get your foot in the door, it makes all the difference. We were talking before at lunch, Hadoop is a very key structure to all main big data projects and all the projects that are out there. If you can get comfortable with it to do some of these things, it'll make all the difference. Okay, so here's what I'm going to show you. First things first, I've got a nice little demo Hortonworks sandbox here. You can go pick this up from hortonworks.com. They've got a new one, the 2.2. This is a complete, file. You just download it. I think it's 3.5 gigs or something. Wonderful little tool to play with to learn Hadoop. Okay, they've got tutorials right there on the Hortonworks site on how to use Hadoop. All right, so please don't reinvent the wheel. Don't go and install your own cluster. Install this little guy and you're done. All right, I used Oracle VirtualBox. You can use VMware Player, whatever you want. So that's up there and running. And what I'm going to show you first is just standard good old SQL. Let's see how well we can see this. Nothing more than a normal query. I'm just using this table so I can show you what data is in it. And this is what I'm going to do. I'm going to pull data from a SQL Server table, and I'm going to push it into a Hive table on the other side. And again, this isn't rocket science. This isn't a huge ETL, but this is the first step. Getting it into these pieces, these are the first steps. Once you start learning these steps, everything else gets easier. So we've got some data in there. This is the baseball data you can download from the website. Just a bunch of player information. I'm not going to go too far in depth into it. So what I'm going to do though is I'm going to open up a PuTTY session as a SSH to that virtual box, and the password is Hadoop. It's a sandbox. That's what I'm connecting to. And I'm going to run the scoop import command. And so that we all learn something here, and I give you warnings, I'm going to walk through the entire command. And like I said, please email me, go to the Google Hangout, whatever. I will give you these scripts. These are not rocket science. I will happily give you these scripts. So the scoop import command is really the basic way to get data into Hive from SQL Server or from a relational database. Now, if you're on Oracle, you have to pick up a driver, a JDBC driver. If you're on SQL, you have to pick up a JDBC driver. If you're on MySQL, it's built in. So if you're on MySQL, be happy. I put the driver up here. No, not that Zoom. There we go. I put the driver up here, right here, the Cloudera driver. I put it up there. It does not come in the sandbox. So when you download the sandbox and you try this, if you don't go and get this driver, it will not work. Okay? I just tell you that now because I ran into that problem. All right, so here's the scoop import command. This is exactly what we're doing. All we're saying is connect to a SQL server. Simple JDBC connection. On the side, there's a username, there's a password. We all know how to connect to a relational database. It's nothing more than any connection string that you normally have. The first entry there is verbose. This is one's really funny to me because, quite frankly, Hadoop is verbose no matter what the hell you do. It's annoyingly verbose. I mean, how much that thing spits out is just sickening. But if you put verbose on there, it spits out even more. So when you're testing, play around, keep verbose in there. When you go to production, please take it off. Table, I'm going to say, we'll give a minute for the thing. Love these things. This is what being in a hospital is all about. Okay, is it done?
Code trauma, alert 2. Code trauma, alert 2. Code trauma, alert 2.
Okay, in this one, I'm going to declare a table that I'm pulling. That's the table I just showed you in SQL Server, state move. That's all I'm doing is I'm moving the table. You can put a query inside here in Scoop. You can write whatever query you want inside Scoop. I will give you a warning. It is best to just go with a table. It's not that great at the big queries that it tries to do. Think about execution plans. Think about queries that has to do locking and blocking.
Code trauma,
Getting a table is a much better way to go, okay?
alert 2.
You say Hive import, that means I want you to put this in Hive, and I want you to create a table for it. Actually, there's another step. No, that's Hive import, yeah. So keep in mind, when you have Hadoop, Hadoop is the HDFS file system. Hive is on top of the HDFS file system. So you can put something into HDFS, and it's not a Hive table, okay? I specifically wanted a Hive table. I don't want to sit here and fight with creating 2 steps. This does it in one, all right? You want to do this to give you that relational feel inside that table. Incremental, last modified. So it goes on and checks the table and it says, what haven't I moved? If I've got a nice little last modified date on there, it knows. It just says, okay, I'm just going to pull over whatever's changed every hour. Whenever you run me, I'll pull over whatever's there, okay? And then check column, that's the column that it's using to say what's last modified date.
That's part of the state move table.
That's the what?
You said
Yes.
that's part of the state.
Yes, I have a column called modified date.
Modified it in
Yeah.
the statement.
In the statement, yeah. So again, you don't have to have that if you do a query or something. If you say, hey, between these times and you pass it in, it's fine. You don't have to do that. It's just they built that in there so that it could do it for you. Hive drop import to lens. This is the funniest one. Well, the next one's the most dangerous, but this is the funniest one. The funniest one because I couldn't figure out what the hell was going wrong with my query for like 2 weeks. I added this and it worked. And I still in the documentation do not understand what it's trying to do. This one also is probably only for SQL Server. It may not be for MySQL or Oracle. So definitely test this one back and forth, but I couldn't get a single thing to import until I added that. And in the documentation it says, oh, it just imports delimiters or something. Like, it doesn't help at all. I do have to say the Scoop the documentation probably has gotten better since 1.5 years ago when I wrote this, but when I wrote this, it was terrible. Terrible, terrible documentation. Okay, so the most important one and the most dangerous one is the last one, -M1. This is very, very important. This will default to 3. 3 will crash your box, okay? Just about every box I've ever tried 3 on, or if you go higher, it will crash your box. Now this means 3 mappers, or 1 mapper. So what that means is that if you say, I want to move this table, and this table has 10 million rows in it, and you have 3 mappers, it goes to the table and it says, give me your primary ID. And I'm going to count it. It's got 10 million. Okay, I'm going to take 10 million divided by 3. I'm going to run 3 queries against your table between those ranges, but I'm going to do it simultaneously. So I'm going to suck up your entire table at one time with 3 statements, and I'm going to lock that entire table as I move it over. So if you're on an Oracle server, a MySQL, a SQL server, you're going to lock that entire table the whole time, and no one's going to be able to query from it. And I have seen this actually crash boxes if you go too high, because it makes so many queries, it does so much work all at one time. Okay, so be very careful. I always suggest to leave this as 1. Do not increase this unless you're ready to change the performance. Yes?
Is there a way to do it query reading so it doesn't lock?
There is no knowledge of no lock in its system. So no. If you're on SQL Server and you were in a snapshot isolation level, yes. But say you're on SQL Server and you're just a normal thing, it'll lock it every day, no matter what. Okay? And again, even think about your large tables, again in Oracle or something else, you're going to consume the whole table. It wants to pull the entire table. And you can watch it do this. You can start one of these up, you can run your query listing, and you'll see 3 of them for that one. Yes, sir?
Are you going to face, do you know if you're going to face that same issue if your data is stored like columnar versus row based?
Okay, the question was, are you going to face that same issue if you're in columnar instead of row-based situations? Well, it's hard for me to say because I don't know how columnar would handle it, but let's put it this way. Whatever the count comes back as, it's going to try to divide it by whatever that number is right there and open up 3 connections. M3 means mappers 3, so it's going to attempt to use 3 queries to move it faster for you. So it's not a bad thing, it's a good thing, it's a performance thing. But if your system's not ready for it, it's a very dangerous thing, okay? So be very careful with it, put it on a test system, try a couple different settings and see how it goes. Ours in production will never leave 1, guarantee you right now. So, okay, questions on the scoop import? I'm getting closer and closer on time, so I want to move through this kind of quickly. All right, down here, I even gave you the exact table I used for the presentation. You can see it right there that I'm kind of scrolling on. I want to make sure you guys can see it. That's why I'm zooming into it. So you can see all I did was the same thing. I just gave it names and stuff. It's the same thing I just went over, just making sure that everybody sees it's not really that much different. And again, this statement is almost identical to what I run in production. I've taken out username, passwords, all of those sort of things. We have ours wrapped in a bash script that passes in variables, but otherwise it's the exact same thing. Okay, so you take this, you come over to your SSH window, and you run it, and command not found. Oh, I missed the letter. Let's try that again. I was gonna say my demo didn't fail earlier. Okay. There we go. And here it comes. Ready? Ready? Yeah. Yeah. It spits. Feel free to read it, but it's not much fun. It's very, very verbose. It loves to say every single thing going on. But let me tell you what's going on while it's sitting there running for a second. It's off running a query against MySQL Server to pull the data. It's going to take that data, it's going to stick it inside a file on HDFS. It's then going to run a command to turn it into a table in Hive. And as soon as it's done, I will show you that actual table that it made inside Hive. Now in here, you can specify things like the database. So in Hive, you can have databases, tables. All of that stuff is in Hive. So you can have it there and you can show it and you can see what it is. We have different databases for our customers because we're a SaaS-based platform. So we have different Hive databases for every single one. Did that finish? Oh, you know what? That doesn't finish when I zoom in. Okay, it did finish 0.583 seconds, not too long. This is not a big table. This is, I think, 10,000 rows. If this was a couple million, it would take a little bit longer. That all comes down to network, copying files, everything like that. So then I'm going to go into Hive. And I'm doing this specifically in the command line just because I wanted to show kind of the differences there. With these sandboxes, there's a Hue interface. There's a graphical GUI interface that you can do it inside there. So don't be afraid of the command line. There is a GUI interface. I just prefer to show it when I do it in here. So I can show databases, simple commands. It's very SQL-like. It's not perfect. It took me about a week to switch my SQL commands, my ETL over into here, mostly because I got used to semicolons and semicolons and then the syntax was a little different. So this one's in the default database. I didn't tell it any specific database. So, and if I say show tables, there you go. There's SQL Saturday move table. I can do a simple select statement from it. Shouldn't be typing in a demo. So that was a new one for me too, limit 100. If you're into MySQL, that's a common thing. In SQL Server, it's top 100. So some of the things like that, there's little syntax differences, but you can see I've got data in that table. Let me zoom that back in. I've got data in that table and there's my table inside Hive. So again, it's not a crazy thing. It's not a big thing. Normally what I'd show you after this, I'd rather talk about some more things, but I'd show you how to connect Excel directly to this Hive table. And again, getting to the point to where now we're using Excel against Hive, we've gotten to that step. We've gotten over the hump of how do we even get data into the system. That's how you get it in and you get started. And there's a Hortonworks tutorial exactly on how to do it. It's just an ODBC connection, but I just want to get back to the other system things we can talk about so we can discuss more of those things. All right, and then obviously you can leave here. See, I forget semicolons constantly. Yeah, right here, when you're looking at the virtual box, I'll see if I can pull it up if I can remember it. 127.88.88, that's your Hue interface. I'll show that to you really quick. Oh, this is the page where the JDBC driver is, if anybody wants to get to it. Again, it's just a link. Yeah, so this shows you the tutorial. See, this is what's really nice about Hortonworks Sandbox. This is what I see first. And right there, you've got start tutorials, videos, whole bunch of settings. It gives you everything. I mean, everything you need is right there to start learning what you need to do. I want to go to the sandbox, and then I get into here, and here's Hue. And so this is the same thing I showed earlier. This is just a GUI version of it. So I could say show databases, execute, and in a second, it's a little slower. Voila, there's my databases, okay? Very similar to a query tool, not nearly as powerful as, say, a MySQL Workbench or a SQL Server Management Studio, Oracle tools, not even close. As a matter of fact, when I first started using this, I never touched this tool because it was so buggy. I hated it. It just drove me insane. But now, the 2.2 version stuff have gotten better. I do recommend it just because it's easier, but you still find me in the command line quite frequently because I'm there anyways. So, and like I said, if I had done the select, that would do that as well. So there you go, same thing. So really no difference. Yes, sir.
How much flexibility does Scoop allow for picking up where you last left off with your ETL and managing reword your database?
So the question is, how much level of flexibility does Scoop help you with, say, a table dies or a process dies or something goes wrong and you want to restart it from the last one? It's actually very, very good because you can, if nothing else, you can tell Scoop, here's my primary key, here's my number. I want you to maintain that number and I want you to keep pulling whatever that number is that's missing. It'll actually do that for you. It'll take care of that side. Now, there's some issues with that sometimes that maybe it loses its own number. Maybe you restart the full name node or something like that and it forgets, or loses that number. So when we did our process, we actually date timed, and then we used date time benchmarks to figure out exactly what needs to move over. And we felt that it was better for our needs for an enterprise class system to maintain its own number system. So we have a config table that says, this is the last time I ran. This is my points that I go between and so forth and so on. So I would say it has great flexibility, it really does. But we chose down our own path because we felt that it was better to have that in our control than to leave it up to something else. So I like its flexibility. The primary key you can look for, the last modified date, any of those things, it can tell very easily. So, all right, other questions while I'm in here really quick. Otherwise, I'll go back to the other side. We can talk about systems. What time am I supposed to be done? I didn't even look.
2:20.
Okay, so we're doing good on time. All right, so some of the pros and cons we ran into in the solution. Some of the things that went well and some of the things that did not. It's very scalable. Like I said, if my ETL wants to get faster, I add more nodes. Add more task slots, I can do more work. Same with my Elasticsearch cluster. When I want to make it faster, I want to handle more data inside it, I add more nodes, which is somewhat working right now. There's some other issues. Cost effective. There's no licensing cost to Hadoop and there's no licensing cost to Elasticsearch. They're both open source software. They can, and if you are going very large, you can buy support, and if that's the choice you make, that's fine. I would say the Hadoop side, you need less support because everyone is doing it and there's lots and lots of support already out there. Lots of it. I've never called on a Hadoop ticket or Hortonworks or Cloudera for any of their settings. I've been able to find everything I needed from the community. Elasticsearch, pretty close. We've been hitting support lately because of some issues we've had. But in other words, same thing. You can buy support from the Elastic company itself and they will give you support. And they do a wonderful job of it. So those are out there. Those are options that you can use. There's nothing stopping you from those. But also cost effective. A lot of people say commodity hardware. You can put it on old desktops. Well, please don't. You should actually still put it on decent boxes. Our nodes are about $5K a piece. They're HP boxes. They are what you would call an enterprise class box. for our Hadoop nodes. Our Elasticsearch are about 10K. They're more expensive because they have SSDs and they have a lot more memory. Elasticsearch being a speed layer wants memory and SSDs for everything. So that's how we chose to do it. There's lots of other options now too as well. AWS, all the availability through, there's Azure and other things. You can go cloud with the entire system. Keep in mind the system was designed for physical boxes. So one thing you never do to Hadoop is you never put a RAID behind it. In other words, you never put a SAN behind it. Don't give it a big giant SAN, that's a waste of time. Hadoop is designed to work off of JBOD, just a bunch of disks. So you give it many, many disks, and then it does its rating itself. It does its movement of the boxes, the data itself. Do not put it behind a SAN. You will regret it. Okay, very extensible. We can write all the code we need. We can do a lot of different things. We have a lot of control with the system because of that. We don't necessarily go into the open source code. You can, but we have a lot of extensibility that can be done inside the system because of it. Cons, there's a lot more work and time to put into it. So the way we made this project work, and what I suggest to people all the time, is don't try to replace your relational database. When someone says to me, I'm going to replace my relational database with Hadoop, I want to smack them, because that's not the tool for the job. That's not what you're trying to accomplish. You should create a new product or a new thing, a new analytics, a new piece that uses the new system, and then work on migrating your old system. We put this up in about 6 to 8 months because we did it for a whole new set of software we were designing. We did not try to replace our relational database. We did not go to our code that was 7 years old and try to say, okay, write to Hadoop. Never work. That's not what you should be facing. You should focus on new technology, make something new, show the value, and then work on converting everything else over. We are currently in the project that our SQL Server is getting smaller and smaller. By the end of the year, we may take our 2 major products completely off of it and move it into the new product we created. So in a 1.5 years' time, we got to where we wanted to go. We didn't try to do it out the door though. We would have failed. We would have never succeeded. Okay, well-trained staff and people. I put this as a con because this may not be your forte. You may be a SQL Server DBA like myself. You may have to learn this. You got to learn a lot about Hadoop, and it's a very different paradigm shift. If I went to a DBA and I said, don't ever put your databases on SAN, they would beat me senseless. They would say, why? But here, exactly, I'm saying, I want you to build a system and not use it as SAN at all. And they'll say, well, why? How is it redundant? How do I protect it? It's all things that have to be learned. So there's some training that goes on. There's people that are involved. You have to do these things. And then longer support times if you're actually trying to get support. Keep in mind that it is an open source system. If you're trying to find support, your best chance is Google's, forums, things like that, or you actually buy support, and then you get a shorter time frame. If you don't buy support through somebody, Cloudera, Hortonworks, Elasticsearch, whatever, you're going to take longer to do a normal support ticket. Oracle's not there, Microsoft's not there to just pick up the phone and say, fix it. It's not there, unless you buy the support. So be prepared for that. So those were some of the cons that we ran into. All right, so I'm going to go back into questions and answers. I'm going to go back to the other slide, but homework, definitely download the sandbox. Please use the Hortonworks sandbox. It's a wonderful thing. This blog right here, this gentleman did my entire presentation in blog form. I was thinking about blogging it, but I'm like, holy cow, I'm just going to reference this and tell this gentleman about it, because he went through all of these steps exactly from the SQL Server aspect. And so it's really, really great blog. And then get your own data. You know, I can't obviously bring one of my tables here because it's customer data, but you can at your office. You can test this. You can play with this. Grab a big table and test it out. See what it can do just on your laptop and your virtual machine. You'll be surprised. And you'll be surprised what you can do with it. You know, it's not that hard. And then get your 90-day proof of concept. Show value in just getting to that step, and you'll make a difference. And you'll start putting something in place. The other big question I get is, do we have to do this in Linux? There is Hadoop for Windows now. It's part of Hortonworks. Microsoft releases it as well. I can't remember the exact distribution. So you can use Windows. There's nothing stopping you. When we started this, no one was using it in production. And I literally mean no one. It did not exist in production. Now, that's changed. You're welcome to try those things. You're welcome to do those things. I have found that Linux works very well for our system, and I would suggest it for anybody moving forward. So, okay. And then finally questions, but I'll go back over to this slide and ask questions on anything else, architectural questions. Yes, sir.
How do you handle deletes?
How do we? Thank you for bringing that up. I completely forgot. How do we handle deletes? So Hadoop, this is another one of those things you have to learn as a DBA or a SQL person. Hadoop can't delete data. Well, Hive can't. There's no idea of a delete. It cannot actually delete a row inside a table. It can overwrite, but it cannot delete. So you have to quickly learn how do you work around not having the ability to delete. So what we did to solve our problem is we push the data in through SQL Server and we say, this is deleted. We actually have a flag that says I've been deleted. It skips right across through Hive and then it hands it off to Elasticsearch. Elasticsearch knows how to delete, so Elasticsearch deletes it. And Hive just completely basically ignores it, retreats it as another action that I have to do. So in that sense, it's a lot like a message format where it says, hey, I got to do some work, and this is what you have to do. But it's Elasticsearch that actually does the job. So Elasticsearch has the ability, Hive does not. So yeah, when you move forward, when you're saying, hey, I just want to update this row in Hive, yeah, it's not going to happen. You can insert overwrite, but trust me, that one's really weird. There's all sorts of rules around how the partition updates and stuff. So test that a lot before you do that. Yes?
Can you talk a little bit more about the Hive to Elasticsearch piece?
Yes, I thought somebody would call me on that one. Hive to Elasticsearch. There's a little thing up there that says load ES and it's a custom jar. So 2.5 years ago, there was no way to directly load data from Hive into Elasticsearch. You could make an external table, but it would not actually load it. So we wrote our own. So we wrote our own custom jar, and actually we open sourced it. I believe that Abby has a Git page on it or something like that, that pushes the data between the two. That's now since changed. They do have Hive to Elasticsearch, but that's what we used, and we are still using it to this day.
You're using your custom one?
We are using our custom one, yes. Because besides the custom, the best way to put this is I would say accidentally put a little bit of business logic in our version. And so, yeah, it does a little more work than that.
Right.
That's something that's got to be removed in the future, but obviously it's there. So yes, we do a custom jar that actually pushes it between there. We also want to control our batch sizes and things like that as to what we're pushing to Elasticsearch, because Elasticsearch is a query engine. It's a wonderful query engine, but that doesn't mean that it can index extremely fast. And if you're trying to send, say, 10 million rows of data to it, you might have to throttle it a little bit, because if you're trying to query data, it's the same concurrency issue. You're trying to query data, trying to update data. You're going to run into problems. So you have to balance that, and so that's why we did that. But it is available out there in open source. And there are tools now that you can just do it. You don't really have to fight it like we did. Other questions? Oh, it's way too quiet of a bunch. Yes, sir.
Because your Hive process doesn't do any significant transformations, at least currently. Did you ever consider writing to Elasticsearch directly and, as you're writing to the database, or rather than?
So change the original. So if we have those three sources up there, you say take the source and actually write to Elasticsearch and SQL Server or something like that. A parallel write. Is that what you're asking?
Yes.
Move into a parallel write system. So the systems that we bring our data into, the main one, our collector, unfortunately, is very old, 8-year-old Delphi code. It's not something we're probably going to intend to change at all until it's completely rewritten. So we just didn't even want to go down that path of trying to say, let's write into here. We discussed a parallel write situation and what it would take, but it wasn't even in the cards. It wasn't even, why even bother trying to go down that path? I would suggest if people can do that, that's a great option and a great thing to do. Just be careful of your synchronization, your failures, stuff like that. When you dual write, you run into more complexity of if this one doesn't make it, but this one does, what happens? So keep those things in mind when you go down that path. We did think about it a lot, but it would have been way too much work to try to make it happen. So.
Along those lines, I think as I envision maybe some of the data you were talking about in your application, I can envision like large text fields, things like that are coming in from your surveys that I really don't want in my SQL database.
Yes.
And so those kinds of things, but I really want to be able to full text search those.
Yes.
So that's where, and we have similar scenarios. It's like I want to parallel write that,
right,
so that I'm not sticking in a database and now
Yeah,
You know,
so.
exporting it and yeah.
So based on data, your comment here is based on data, find the right actual source for it or where to put it instead of places it doesn't need to belong. And that's absolutely, and that's what, when I mentioned to these guys too, and I'll mention to others, version next or our next step is going to start relating much more to that. We are going to process based on the data coming in and then do different processes and store in different places. So the most common question I ask my team is, what is our system of record going to be? Because we do not see SQL Server as our permanent system of record. We think that someday it will change. It will change, it will be removed entirely. So, and by when I say what is our system of record, it may not even be a relational database. But to this point too, it may not only be one thing, it may be several things. So based on data type, you could have a different system of record. If you process things like text or text analytics, and all you want to do is take that text and dump it onto HDFS, and then process it, and then you just leave it there, there's nothing harm in that. You know, if it doesn't modify it, it doesn't change, if you want to reprocess it, you grab it again and you do it again. So there's lots of options like that. You can't limit yourself to, I must put everything inside one place and then do work on it. You have to think about multiple things, okay? You have to think differently is really what it comes down to be. That's why I ask my team that question more than anything else. It's not to say SQL Server is bad or it's terrible. It's just to say, what else can we do? We are hitting limitations. Why or what else can we do to change those situations?
Well, and like the scenario we have, there's a tie really in that I want to be able to do full text searching and then discover the documents, but then go back and get information from my relational database.
Yeah. We do that.
So there will never really be, the relational database is not going away
Right.
as a sort of system of record.
Right.
Neither is the documents we want to search.
That's an excellent point. So your point is sometimes you can use a great search engine like an Elasticsearch or something and find something really quickly and then go take the ID and go get something from a document store. We're actually looking at that right now. We do that with SQL and Elasticsearch right now. But we're also looking at moving to an H-based system where we can export faster out of that. Because Elasticsearch is great about finding a record. But then if you said, I want to export 1 million documents, I want to send out 1 million responses, how do you do that quickly? You've got to pull together 1 million documents and then export them. It's very slow. But if you told HBase that here's my numbers, I want to do these 1 million, it would be one query to get that column family and send it out. So it's using the right tool for the job and getting those things to mix together. And so right now we do that with our SQL database. We'll find certain numbers and then we'll take those numbers to SQL and say, give me that information. And it does it quicker. So pairing those together, that's really the key. You had a question?
I think you answered my question just now. I was going to ask, how do you arrive at choosing Hive rather than straight to HDFS or HBase?
Okay, so Hive, okay, so that's an excellent question and it's a little different. And I'm glad you asked it. So a couple years ago, I was sitting at the PASS Summit, the largest SQL Server summit in the world, all about SQL Server. And they did a great presentation on big data. And they got up there and they talked about it. And then they said, okay, so here's how you get started with big data. There's this code called PIG. And here's what you do with it. And you write this code and you had this whole room of DBAs that said, how do I write code in PIG? What do I do? What am I supposed to do? Like, nobody had a clue. Well, Hive is SQL. It's just SQL. We know how to write it. It's the same thing that we've always done. It's select star. It's insert. It's all the same stuff. Hive was a no-brainer. Like I said, it took me 2 weeks to get a SQL query that I ran all the time in SQL Server to run in Hive perfectly. I mean, syntax changes, everything. Whole design, my ETL that I did was 2 weeks of time. That's it. If I had done that in Pig, it would have taken me months, 6 months probably. And I would have had to learn a whole new language and everything else. So the reason for Hive over any of the others was simple. It's the easiest thing to use. Now, that was 2.5 years ago, or about 2 years ago. Now you have Impala, you have Tez, you have other things. You have SQL on Spark. Everyone is getting the idea. You have to write SQL against these technologies because there are millions of people out there that know SQL. So all the tools are getting SQL interfaces. So again, you were scared before because somebody showed you Pig. Say, no, I can use Hive and it can do the exact same thing. Now maybe it's not as fast. Pig would have been quicker to do the ETL, don't get me wrong. It would have been a better tool for it. But it would have taken us another 6 months to write it. and we would have had more support, more issues with it. It would have been so much harder. So use the tools you already know. I've got lots and lots of developers. We merged as a company. I've got lots of developers that know nothing but SQL. I'm going to turn them loose on drill. How many people have heard of drill? Got to go look up drill. Really, really cool. Drill is nothing more than SQL statements against files. And then the cool part, though, is not just that you can query against files, but you put those files on a horizontally scalable system like Hadoop, and now you can query really big files really quickly. So, and all it is SQL statements. That's it. I gave it to one of my ETL guys. In 2 weeks, he had an entire drill set up running and go. And it's all because it's SQL. He knows exactly how to write a join. He knows how to write where clauses. No problem. Try to process files like that in Pig or something else, it would take months. So that's really the reason behind the Hive connection. It was simple, it was easy. Now you have Tez and Impala. I suggest if I had to rewrite now, I'd probably go down Tez or Impala because they're in-memory Hives. They're faster, and you need it to be quicker. But it's the same thing, it's the same concept. It's still SQL statements. So if you're really good in SQL, if you're a DBA, if you're a person like that, use the tools that already are there to use SQL stuff. And like I said, really take a look at drill. If I had to redo this, we'd probably start with drill because drill is really cool. So great question. Any other questions? Yes, sir.
Just one last question for me, but if this is only one database instead of 500, would you ever explore this route?
Okay, so excellent question. If this is one database instead of 500, would I have ever explored this route? So a quick little history lesson. In about 2003, I think, I can't remember that far back, I worked for a company called 1-800-CONTACTS, wonderful company, we're right here in the Valley, and we designed a horizontally scalable system with SQL Server. We put it all on paper, we showed read slaves, master slaves, replication, everything we could do to design it. Never saw the light of day because of the costs. I've been trying to make a system like this, regardless of how many databases I've had, for years. So I would have done this if you gave me half a database because of the simple principle of this separates my data, it gives me horizontal scalability, and it's cost effective. That's why I do it. That's why I wanted to do it. And anybody that's out there that says, I don't ever need this, wait 5 years and ask me again. And I will tell you, yes, you do.
Just 3 years now.
Yeah, 3 years, whatever. Because everyone that tells me, we don't need this, or we're sick of hearing about big data. We can do these things in these vertical systems. A vertical system, by definition, has a ceiling. If you are a company that is growing, you don't want ceilings. It's that simple. Dave, you can answer this better than anyone from a business perspective. He doesn't want limitations. Not at all. So I don't mind if you come out of this and say, he's crazy, don't ever need this, that's fine. Come see me again in a couple years and we'll have a chat. And we'll see if that changes your mind. Because I would love to pull up the graph, I've done this before in the other ones, of how much data we're growing each year. It's some wacky numbers, zettabytes or whatever. It's crazy. And you guys know this. You're in your systems right now. I mean, how many people are buying more SANs right now? How many people are buying more disks? Data's not going to stop growing. It's not going to stop getting bigger. And people are not going to stop asking questions. That's the really key. And they're going to ask harder questions too. And that's the difference. So excellent question, Dave. Thank you very much. Yes.
In terms of data storage, are you setting these up so that they store your data indefinitely, or do you roll stuff on?
Excellent question. So that's really good. When we started out, we said, why don't we put this into Hadoop? And so to give you some background, my Hadoop cluster is about 4 nodes. That's it, 4 nodes. It has 22 terabytes of space in it. Because again, a Hadoop cluster has many, many drives. So I have 8 2-terabyte drives in every box, so I have about 22 terabytes to play with. So we said, well, we can easily fit our customers in there. We're only talking about 2 terabytes on the SQL side, so let's dump them in there and let's keep it. We found that we actually ran into slowness issues by keeping it around because it kept trying to go back to the partitions and look at all of them as it was bringing data over. Since we're doing a batch processing system of once an hour and we have a nice master system of records sitting there, we're like, why bother? Why do we need this? Anytime we want to rerun, we go back to SQL and we just rerun. So no, we don't store inside our Hadoop. Our Hadoop hourly batch is probably somewhere to the tune of maybe 500 gigs or so, maybe less. Every once in a while, it'll spike up. Like last time when we refreshed some customers, went up a little bit. But otherwise, it's pretty transient. For us, our Hadoop nodes are transient. They bring data across, they do what they need to do, and they drop it. And then they keep going over and over and over again. Much like a staging table in a data warehouse, exactly how we designed it. But can you keep it in there? Absolutely. One of the best uses of HDFS and Hadoop is long-term cheap storage. Again, 22 terabytes, and it cost me probably $20,000. That's it. And it can stay there forever. There's no licensing costs. I can stick a ton of database data in there and never worry about it going down because Hadoop keeps 3 replicas. So is it long-term cheap storage for archive, for text analytics, for documents or something? Absolutely. If you ask me now, I want to make an archive in SQL Server or something, I would never do it. I'd make it a Hadoop cluster. I'd stick it on Hadoop and say, I'd put a storage record in SQL and say, that's where you go get it. Go get it. That's it. It's absolutely the best cheap storage out there, hands down. So excellent question. No, we do not store all of our data in there all the time. We tried, and we may change that. When we start talking about HBase, the HBase situation I was talking about, we will do it then because then we'll have a need. HBase will have to pull the entire data set. So it'll have to live in there, not just a batch. So when we get to that point, we'll probably keep it. And then we'll have to work out some of those partitioning issues we had before. But yes?
If you have time for this, how do you handle deltas, changes to existing records?
For us, in SQL Server,
Through all the way, all the way through to Elasticsearch.
so the question is, how do we handle deltas? How do we run our batch, essentially? For us in SQL Server, we have modified dates on our tables. We have triggers that tell us when they're modified. The ETL process or the stored proc I talked about, that stored proc detects what's been changed, dumps it into the tables for Scoop, and then Scoop passes it across. And then it does all the work throughout there. Again, we know when it's a delete, and we have Elasticsearch or something else delete it, but it runs through that batch. So it is getting a batch every time. It says, these are the 1,000 people I have to process. These are the 500 people I have to process, so forth and so on. Each day, each hour, as it keeps going through. That's how we handle it. And if somebody deletes or modifies, it comes up as a modified date, we send it back across again.
Okay. But you can, and you have something you're using to identify that doc in Elasticsearch.
Yeah, the Elasticsearch uses a key. Yeah. Elasticsearch, so Elasticsearch deletes, it has to blow away the doc and recreate it. That's how it does its deletions. It just does it in an indexing manner. If you think of something like a SQL Server index, it adds more data into it, chunks those pieces off, and then it flips them and puts them in place. There's a merge that goes on.
That means there is a key, there's a common key.
Absolutely. Absolutely. Yep. There's a common key that keeps them in sync. Yep. So, and as we get new data types and new document data types and stuff, those come up. We create their key, and that's how we really go away. Okay. What time is it? 2:20. I think I'm right about at time, right? Didn't we say it was about 2:20? Okay. Happy to answer any more questions. I will be here all afternoon, probably sitting at the registration desk. Other than that, I'm complete. I hope everyone has an excellent day. Thank you for listening.